And now we're going to be going over part 2 or part B of the traversal question. So notice that it is possible for two different tree traversals to produce the same ordering. And if you look at this example here with a parent of 1 and a immediate left child of 0, you will notice that the post order and the in order traversals are both 0 and 1. And if you look at the tree from the previous part, we notice that none of the traversals produce the same ordering. However, we may be able to remove some leaf nodes from the tree such that running 2 of the above traversals, which are 2 of the following pre-order, in-order, post-order, and level order on the modified tree will produce the same ordering. So by prioritizing the minimum amount of leaf nodes possible, we need to select the leaf nodes that need to be removed and the 2 traversals become the same. The easiest way to go about this is look at the traversals that we were able to make in part A. And I've went ahead and I've copied them here. And off the bat, we can see that there are a couple of traversals that look very similar with just a couple of mismatches. And we can sort of go about looking at those first before going on to other options. And as we can see here, the pre-order and the level order traversals off the bat look pretty similar. The only main differences here are that 0 and 5 are swapped and that 7 and 3 are swapped. And so if we want to sort of remove some of the nodes, we need to consider either 0, 5, 3, or 7, because those are the only mismatches here that prevent us from having traversals that are the same. And the easiest way to go about this first is look at parts of each traversal to see what we can modify to make them equal. So let's look at the first 3 traversals. So let's look at the first 3 nodes to observe in this pre-order traversal. Here we have 2, and then 1, and then 0. But then in the level order, we have 2, then 1, then 5. And then actually 0 comes after that. And what you can see is that in order to make the same, I just added a 5 for the pre-order traversal, we can actually remove the 0 node here. And the reason why is that when we do a pre-order traversal on this new tree, what will happen is that there are going to be no children left on 1 to examine. And so we can simply just move on to the right child of 2, which is 5. And so when we do the level order again here, we will notice that we have 2, 1, 5, but we don't have to examine 0 anymore. And we can go straight on to the next part of it. And the next part here are 4, 7, 3, 6, 8. And that's the level order version. Let me just go ahead and fix this up. Okay, so the rest of the tree that we can, rest of the traversal that we can examine is the following. 4, 7, 3, 6, 8. This is for level order. And for pre-order, it would be 4, 3, 7, 6, 8. We notice that these 2 are the same, and these is the same. So we need to figure out how we can actually remove one of the nodes in this subtree to prevent this swap. And the easiest way to do that is actually remove 3. And why? That's because when we do a pre-order on this subtree, what will happen is that we go from 5 to 4, but then 4 has no children left, so we go to 7. And then on this next subtree, and then if for level order, it would be 5, 4, 7, and then 6, 8. It's the same. It will then basically be the same. It's just without 3. And so what we've finally been able to figure out here is that 0 and 3 are the leaf nodes to remove. And thankfully, we were able to see that choosing the pre-order and the level order traversals first actually are the correct traversals that can be the same when modified